Here we have another alternating series that we're looking about the convergence or divergence of. Let's see if we meet our conditions for our alternating series. As I look at this piece of this needs to always be positive, and it is, because our domain is from 1 up. Now the next thing we want to do is see if it is decreasing. Well, let's look at a function that has this as its integer values, and let's go ahead and take the derivative of this function. So we have a product rule, first times the derivative of the second plus the second times the derivative of the first. We could factor an e to the negative x out, and we see we would have negative x plus 1. We'd see if we used 1 here that this would be 0, the derivative would be 0, and for anything greater than 1, this derivative then is going to be negative, because we can see if we have this number right here, x greater than 1, we're going to have a negative here, and this is always positive. So this series does have decreasing terms as long as we have n greater than or equal to 2. So it doesn't matter that we can leave off the first term. If we determine the convergence for n greater than or equal to 2, it'll have the same convergence if we had n equaling 1, because we'd just be adding on one more finite term. So now let's look at our third condition. Our third condition, we need to take the limit as n goes to infinity of n e to the negative n and make sure that that goes to 0. Well, we have an indeterminate form here, but it's not in a form where we could use L'Hopital's rule, but I could express this and move this down, and we see now we have an infinity over infinity. So we could use L'Hopital's rule, and we have limit as n goes to infinity of 1 over e to the n. Now that we have a fixed numerator, denominator becoming large, we can see that this does go to 0 as the denominator goes to infinity. So we've met all three terms. So by the alternating series test, this series converges.